Right, so relating to the normal distributions, thing called standard scores. So standard scores, sometimes you hear them called Z scores or standardised scores. Right, any of those three terms refers to the same. So, to calculate our standard score, and the standard score is the Z, we do the following. So what standardised scores do is they create this Z score or this standard score, which you can then compare different things. So our standard score or our Z we take our actual score that we got, we take away the mean, and we divide it by standard deviation. There's different data sets would have different means and different standard deviations. So different data sets would have different means and different standard deviations, and by using this, we get this standard score that we could then compare. So if you wanted to know how you went in history as compared to how you went in maths, for example, you'd go onto the VCAR stuff and you'd look at the means and the standard deviation of each of those subjects, and then your score, work out this Z score, and then the one that has the higher Z score would be the one that you've performed better in. So in symbols, that looks like this. So in symbols, it's Z, that's where the Z score comes from, equals X, the score you got, minus X bar, the mean, over S, our standard deviation. Alright, so this Z score that we get indicates how far away, in a sense, we are from the mean. So a positive Z score means that you're above the mean. And the bigger that number is, the further above the mean you are. Zero Z score is on the mean. And a negative Z score is below the mean. All right. So let's do a couple of examples. So let's do a height one. Alright, so with this you'd need to know the mean and the standard deviation, which we're given, and then the height of a particular person, in this case Jane, and she's 150. Now we can already see by just looking at Jane that she's lower than the mean, so we would be expecting to get a negative Z score out of this because she's shorter than the 160, which is the mean. But the score will then give us an indication of how far below that mean that she is. So our mean is 160. Our standard deviation is 8. And Jane, which is X, she's 150. So we use the formula. So Jane's height, 150, minus the mean, 160, divided by standard deviation is 8. Negative 10 over 8, which is negative 1.25. So what this indicates, the negative is shorter than what the mean height is. The 1.25 means that she's 1.25 standard deviations below that mean. So if you remember last time when we had our bell curve, so one standard deviation below was there, and so remember there was 68% in that section there, and so there's 16% in this section there, and so Jane's in here somewhere. So in terms of females, so 150, yeah, she's quite short in comparison to that whole population. Alright, so that's what our Z score kind of is indicating. Alright, we'll do another example of that one where we're looking at, in this case, example that I used before, comparing a couple of different subjects. So this fella, Freddie, So in this particular sort of question, so it says here Freddie's got 74 in maths and 63 in English, and in the final bit there it's which he performed better in. So initially you'd go, oh, it got more here than here, so it performed better, but it depends on what that comparison is. So if it's in comparison to the groups, so in which group, the maths group or the English group, did Freddie perform better in, that's when we need to take into account the means and the standard deviations of each of those, and then come up with a way of comparing the two. And as I mentioned, it's the Z score that we use to compare. So let's work it out. So for maths, Freddie's Z score would be his score, which is 74, minus the mean for maths, which is 60, divided by the standard deviation for maths, which is 12. Because I've prepared this earlier, it comes to 1.17. And for English, Freddie's Z score would be his score for English, which was 63, minus the mean for English, which was 50, divided by the standard deviation, which is 8. And when you work that out, you get 1.625. So in terms of Freddie's performance in the groups, he's performed better in the English group because he's got a higher Z score, 1.625 compared to 1.1. So he's further above the mean in English than he was in maths. All right. So English, since the Z score is higher. Now, I've just talked about Z scores being higher. There are, in fact, situations where it's better to have Z scores that are lower. Can anybody think of anything where a low Z score might be preferable? Golf? Golf, that's right. So golf would be, the lower the Z score, the less number of strokes that you take for the round of golf. So that would be an example where you'd be looking for a low Z score. So what you need to do, and you need to look at what we call a story. So we need to look at the story.
As in the written part of the question?
As the written part of the question, yeah. So is the story about golf? So if the story's about golf, you want lower, don't you? If the score's about a running race, you want a running race. Is it better to be quick or slow? Quick, so you want to be shorter time, yeah? So again, that's another one where a low Z score. If you're talking about tests or exams or something like that, where you want a big number, then higher Z scores are better. So you just need to read the story. So you need to read the story. So the words of the question. So the words in the question. To decide if a lower or higher Z score is best. And things like tests. Let's say high jump is another example where high is better. All sorts of things like that. For those sorts of things, higher is better. And things like race times of golf, race times. Lower is better. Alright, so in the story and the words you just need to think about what is it they're talking about, what's preferable, do we want to score? Do we want it to be big or do we want it to be small? Golf, we want small number of strokes. Running races, we want shorter time. So anything that's like that, the lower is better. Anything like high jump, you want to jump higher. Throwing the discus, you want to throw longer. So anything where you want a big number, then higher is better. Alright, anything else I need to clarify here about the Z scores? Nope. Alright, that's it then.